Today we're going to look at a centrifugal governor, and I'm going to talk you through some of the components, explain how it works and what it was actually used for. Now the word governor actually means boss in English, or chief, and the reason it has that name is because it was used for control applications, and it would control, for example, the speed of an engine. Now the term governor is still used today, although obviously things have moved on in the last 150 years. And we don't really have mechanical governors, or especially not like this. We have more electronic governors, although there are some mechanical governors available, but it's not as common as it used to be. So let's dive in now and have a look at some of the components. We can see below the governor, we have a bevel gear arrangement. That's these two gears here. One is vertical, one is horizontal. That is a bevel gear. We can see the drive shaft coming in along this horizontal axis here through the wall, and the drive shaft will be coming from, for example, an engine, and it will be fed from some sort of gear or pulley arrangement. So as it comes through, it's going to drive the gear on the top, the one that's horizontally orientated. That's going to spin, and then we're going to come up here to our centrifugal governor. Now the centrifugal governor is the whole piece of apparatus that we're looking at now. At the middle, or in the middle, we've actually got the spindle, and on the lower section we have a sleeve or sliding sleeve. On the outside, the two round objects you're looking at, these are weights referred to as fly balls, and then we've got two linkages and two arms. Now what's going to happen is, as the centrifugal governor accelerates, or as the whole thing spins, you're going to see the sleeve, the lower piece, moving up and down. And as it moves up and down, it is going to move this linkage, this whole arrangement here, and that is going to then open, or at least change the position of, this valve in there. So I've talked you through how it works, but I probably should have just showed you. It would be a lot easier. So let's check it out. So now it's spinning, and it's spinning quite slowly. Now it's increased in speed, so the spindle has moved up slightly. Let me just back that up again and I can show you again. Spinning slowly, increase in speed, the fly balls move out, and now they're at their furthest position. Notice that the fly balls now are extended further out from the sleeve than they were originally. So what's happening is, an engine, for example, will be rotating at a certain speed, let's say 100 RPM. And it's going to rotate the horizontal shaft at 100 RPM, assuming that the horizontal shaft is geared directly. So we've got 100 RPM on the horizontal shaft, and we're going to transfer 100 RPM through the bevel gear here and to the centrifugal governor. If we back up now, we can have a look at 100 RPM. Just start it off. There we go. So notice the arms are not particularly far away from the sliding sleeve, but as we increase speed, let's increase now to 200 RPM, the arms have moved further away. They're getting thrown further away by centrifugal force. Now, if we speed it up even further, we can see the arms now are really quite far away from the main stem or the spindle. So as we increase in speed, the weights or the fly balls are going to get thrown further and further away from the central stem. And as they do this, they are going to put up this sliding sleeve, which is this section here. You can see the linkages only allow them to travel so far, and as they move out, the weights, they're going to pull the central sleeve upwards. So we've got three different speeds there, 100 RPM, 200 RPM and 300 RPM. And we know that as it increases in speed, the balls will get thrown further and further outwards until they reach their maximum limit. So all we're doing really is taking the speed of the engine, and we're sort of representing that by this governor. But the governor has been connected to this lever type arrangement. You can see it's jumping from there to there, and then it's jumping down. And if we spin around, it's then coming along here to there. And finally, we can see I've got a control shaft coming through. It comes through the wall or through the pipe, and we have here a valve. So we've got here a valve, looks a bit like a butterfly valve, very old one. And what we can do, if I zoom out again, I'll try and get the governor into the picture at the same time we can see the valve. So let's have a look. Okay, so the governor is slowed down now. We're at 200 RPM, and this valve now is only, say, halfway open. So that's something we call throttling. And if we go again, it is now pretty much fully open. And we can see the governor, you can see the arms have come down again. So let's see if they come down further. No, it's as slow as we go. Okay, so zoom out again. Let's run through that again, just a little bit more. Okay, change position. Now it's throttled because it's running at 200 RPM. And now it's running at 300. Let's imagine that's, very, very fast. And the valve here is now closed. So why would we set up that centrifugal governor like that? What's it actually doing? Well, the reason we set it up like that, let's imagine that in this pipe here is a lot of steam. So here I'm on a bit of steam, I'm coming along here and I get stopped by the valve. I'll push play. Right, the valve now is throttled, it's half open, which we know is 200 RPM, and the steam can flow through again. So what's going to happen now? Let's have a look. If we go backwards, it's flowing through. However, maybe the engine or whatever it is, the steam that is coming through there has not taken effect yet. So the engine has not accelerated yet. Imagine we've got a steam engine. So we'll keep playing it. Now it's fully open. And if we're allowing all of that steam to pass through the valve and go to a steam engine, then the steam engine should start to accelerate again. And that's exactly what happens. Look, see, now it's accelerated. And now it is operating at maximum speed or near maximum speed. So we want to close the steam inlet valve. And using this arrangement, we can control the amount of steam fed to the steam engine. And then if we control the amount of steam going to the steam engine, we can control the speed of the engine. And this is really cool. It's a very simple way to control the speed of the engine. It means we don't have to have somebody there constantly opening and closing a valve. And it does it all fully automatically. And that is essentially what a centrifugal governor does. Again, now we're fully open, we want the engine to increase in speed. The engine's increased, so we close the valve bit. Now it's going too fast and we've completely closed the valve. And that's it. And it'll toggle between these sort of 3 different positions. And you can set them up so they're a lot more accurate, so the tolerances are sort of a lot finer. For example, imagine you wanted it to operate at between 1300 RPM and 1500 RPM. Then you can set the valve up and the governor to operate like that accordingly. It's a very old design, but very simple. The Victorians really did know what they were doing concerning mechanical engineering, and personally I find it quite a wonderful piece of machinery.